Now on this question we're asked to evaluate an integral. Before I start, I'm going to explain briefly how to evaluate an integral. So imagine we have an integral of a x dx with no limits. So this integrated would be a x. Now we increase the power of x, so it will become ax squared, and then we divide the constant by that new power. So a divided by 2 x squared, and since we don't have a limit, we put plus c. Okay, this is just a brief explanation of how to integrate. So as I was saying, to integrate this integral, we add a c because there's no limits to it. However, in our integral there's a limit from 1 to 2. The smaller limit will be always at the bottom. Okay, to do this one, the first thing we do is open a square bracket and then we integrate. So this will be 6x to the power of 3 divided by 3, as I explained earlier, and then plus, since 8 does not have an x next to it, so it's like having x to the power of 0, because x to the power of 0 is 1. That's why we don't see it there. So this becomes 8x, and this is to the power of 1. We don't have to divide by 1 because it's always the same. And then we close our square brackets and we put our limits in, so 2 and 1. Before we go to our next step, we will simplify this. So 6 divided by 3 is 2, so we'll have 2x cubed, and this is our integral evaluated. However, we have given limits, so we got to put this limit wherever you see the x. So it equals to 2 times 2 to the power of 3 plus 8 times 2 minus our other limits. So 2 times 1 to the power of 3 plus 8 times 1. And this is our equation. Now we gotta simplify this, and it's quite easy. So we get 2 times 2 to the power of 3. 2 to the power of 3 is 8. So we get 2 times 8, so that will be 16 plus 16 minus 2 times 1 to the power of 3. 1 to the power of 3 is 1, so that will be 2 plus 8. And this will be 32 minus 10. There, 32 minus 10, which is equal to 22. And that is the answer to part A. Okay, so for this question we're given an equation y equals to x squared plus 1, and we gotta sketch the curve and then find the area between x equals to 0 and x equals to 2. So this basically means that x equals to 0 and x equals to 2 is our limits. So it's basically like the question we did before, but we gotta think how to sketch y equals to x squared plus 1. So before we sketch y equals to x squared plus 1, we gotta think about how we're gonna do it. So I think the best way is to actually just do the graph of y equals to x squared first. And how does that graph look like? Well, let me tell you. The graph of x squared is this graph here. It's just a sketch, not drawn to scale, but it's what the question asks you to do. So this is the graph of y equals to x squared. As you can see, it's a U-shaped graph in a positive. If it was negative, it would be n. Okay, but the question is not asking us to find the graph of y equals to x squared. It's asking us to find the graph of y equals x squared plus 1. So what this basically means is that any value we get for y will be added 1 to it. So as you can see, if x equals to 0, y will be 0 plus 1. So that means the graph will essentially just move up to 1. And this is the graph. So next step is to integrate the curve between 0 and 2. So this part here, we're going to find the area in this part here. How do we do this? Well, the question gives us a hint. We got to integrate to find the area. Some questions might not say integrate, so you got to remember that integration finds area. Differentiation finds gradient. Okay? Now let's go. This will become x squared plus 1 dx. Now this is the part where you got to be careful. We're given two limits, 0 and 2. This basically means that we got to add limits to our integrals. So the 2 goes here and the 0 goes there. Remember, smallest to the bottom, biggest to the top. Now let's integrate this. Just open your square brackets, and now this will be x cubed over 3 plus x, because it's a 1. 1 becomes x, and this will be from 0 to 2. Now think about this for a second. One of our limits is 0. This means we don't actually have to take away the limits for 0, so this will make the equation much easier. However, you've got to be careful to make sure that these are all x's. If there was a constant, we would have to use 0. So this basically means that the final answer will be 2 to the power of 3 over 3 plus 2. This will be our answer. So this is 2 to the power of 3 is 8. So that will be 8 over 3 plus 2. Now this is not the final answer. We gotta simplify this further. So make the denominator the same. To do this, we do 8 over 3 plus 2 times 3, 6 over 3. And this will give us a value of 14 over 3. And that is the area underneath the curve from 0 to 2. Okay, so now for this question, we gotta differentiate functions. The first function is y equals to 4x sine x. Okay, before we do this, we gotta think. These two values are not one function. They're two functions put together. This is 4x and this is sine x. They're different things. So to differentiate something like this, we're going to need something called the product rule. The product rule states that when y equals to uv, dy by dx, so the differentiation of x in terms of y, is equal to u dv dx and plus v du dx. So before we do this, we got to differentiate each term and then use the product rule to get dy dx. Now let's apply this then. Let's make u equals to 4x, and then we do v equals to sine x. So we got u equals to 4x and v equals to sine x. Now we got to differentiate one by one, so du dx will be, let's differentiate first. Okay, so when we have ax to the power of b, to differentiate we basically do a b x b minus 1, and this basically means that the constant in front of the variable will be times by the power, and then the power will be decreased by 1. So this will be 4 times 1 x to the power of 0, so that's 1, and we get 4 at the end. Now for dv dx we got to use trigonometry to differentiate sine x. If you have y sine x, the differentiation of y will be cos x, a positive cos. So that means this part here becomes cos x. Now we got to use the product rule that I mentioned earlier. I'm going to remove this to not confuse anyone else. So dy by dx, we're using product rule, so it says that we should put u first. So u is 4x times dv dx, so cos x. Now plus v, which is sine x, times 4, which made me think that I should put the 4 before, so we get 4 sine x at the end, and that is the answer to the question. 4x cos x plus 4 sine x. That is the answer to part I. Now part II is different. We don't have to use any product rule, it's just simple differentiation. So let's do this in one go. dy by dx will be equal to 3x squared plus 4x minus 8. Now why is it that we don't use 10? Because 10 does not have a variable x in front of it, so we do not use it. And this is the answer to the question.